What's up everybody, how's it going? In this video, I paired up with my friend Camille, who goes by the name Errichto online, and we decided to do a coding interview, where I interviewed him over Google Hangouts on a Google Doc. Now the cool thing about this is that Errichto, or Camille, is a competitive programmer. He is super good at the types of problems that coding interviews test you on. He was, I think, second place at the Google Code Jam competition back in 2018. He has his own YouTube channel, which I'll put a link to in the description and comments below, and you might have even seen him in a video interview of him on YouTube about a month ago that got a ton of views. So I think this video is going to be really insightful because you'll be able to see how someone like him, who's so good at coding interview problems, approaches and solves a problem in real time under pressure. I want to add that this is exactly the type of coding interview that you could expect to get at a big tech company like Google. I interviewed dozens of candidates at Google, and this is really how I conduct interviews, minus the fact that here I know Camille, so maybe there were a few moments where, we exchanged a little bit of banter that I wouldn't do otherwise with a real candidate. But it really is how I conduct interviews, so I think you'll find it valuable. On top of that, the question here is a very hard one. It's actually a question that we have on AlgoExpert. By the way, if you're preparing for coding interviews, check out algoexpert.io, my company. Use the promo code CLEM, C-L-E-M, for a discount on the platform. But so it'll be really interesting for you to see how Camille solved this problem in a way that I had actually never seen before. At the end of the video, we have a short debrief session where we talk about how the interview went, and on top of that, I just filmed a very small commentary that I added in the middle of the interview just to kind of share my thoughts about how he did during the first half of the interview. With that, enjoy the video. Okay, so Camille, I just started the 45-minute timer, and we're going to dive right into the coding interview question. So I want you to imagine an XY coordinate plane, right? You've got the x-axis, you've got the y-axis, and you've got coordinates on the plane. Does that make sense so far?
I did. Yeah.
Okay. And
I can handle 2 dimensions.
You can handle 2 dimensions. So
yeah, with like 11, it becomes hard, I guess.
Right, up until 10 it's okay, but at 11 it becomes difficult.
Exactly.
So I'm going to give you a list of XY coordinates, so Cartesian coordinates on the plane, and I want you to write a function that is going to tell me how many rectangles are formed on the plane by these coordinates. So for instance, if I give you this, you see how I copy-pasted like 6 dots, yeah. Right? You can imagine that the x-y axes are maybe like here at the left side. That's the y-axis, and then the x-axis. It doesn't really matter. And you can imagine that here there are 3 rectangles that are formed, right? There's one that's sort of like this first square.
Yeah, there are 2 squares, the left one, right one, and there is the big rectangle.
The big rectangle, exactly. So I want you to write a function that takes in these points and that tells me how many rectangles there are. There are 2 little caveats. First of all, a rectangle has to have 4 corners on the plane to be considered a rectangle. So for instance, if I delete this one, then you lose quite a few. I think you lose 2 of the rectangles. And
I agree. Yep.
And then the second thing is, for now, we're just going to deal with rectangles that are parallel to the x and y axis.
Yeah.
So they're
this was going to be my question: what would happen if I added a row here, and now would these 4 points, would they create a rectangle that I should count?
So for now,
I guess for now we don't.
For now we don't. For now we don't.
Okay. Well, I don't know if you're aware of that, but I'm quite good in computational geometry, so it's up to you if you want to leave this problem as it is.
Let's leave the problem as it is, and we'll see if we can improve it soon.
That's fine. Okay, so we want to count rectangles made of 4 of points from here. They should be parallel to axis. I guess the professional word for that is like isotic. There is a word for that, I don't remember.
Yeah, there is one word.
It's something with I. Anyway, I would say that we're looking for such quadruples, like say x, y, then the other point has the same coordinate x, but different y. then some different x, y, x2, y2.
Yes.
And now I will also make my screen bigger. And we are looking for fourths of points like that, where x and x2 are different, because otherwise we would count the degenerated rectangles with like 0 area.
Yeah.
And y is not y2. And this is our goal. What makes sense is to iterate for sure over 1 point. So I'm not yet sure what I'm going to do fully, but some pseudocode would be that I iterate over 1 point in points. And this will be my x and y.
Right.
If I was able, for example, to iterate over the second point with the same x, in brute force way, it would be p, let's say, above in points as well. If px is equal p above dot x, and not to overcount something, let's make this p above to be indeed above, so y coordinate will be bigger. If that, then we continue. And what I found is a pair of points that is, one is above each other, like this pair.
Right.
And I need to find matching pair that is on the same level. If here I would just increase some counter by 1, I would count like vertical lines that can be created.
Sure.
And instead, here I will say that what matters are variables py and p above y. Also, I hope that writing in C++ like code is fine.
That's totally fine, yeah.
We have py and p above y. I want to count the number of other pairs that produce the same pair. My idea is to here increase the count for a pair py p above y, where this is, say, a map or a hash map. For now, in C++, I would start with a map from pair to int.
Right.
I called it count. Count. This is count pair y pairs like this, like with this y and this y coordinate.
Right.
Kind of count vertical lines. This will give me logarithm complexity. What I could also do is put a hash map here and an ordered map, and then to make it work in C++, I would need to define some hash value of a map. I think it isn't there by default, at least in C++. But for now, it isn't important for the logic. This way, I count that, and maybe just before, I would say answer plus equal count of same. So not to repeat something, I will, assuming that coordinates are ints, this pair of y, I will call make pair py p above y. Let's not make it ugly. And here increase the answer by count of that, and increase the count of this pair.
So basically,
this way first.
So sorry to cut you off, just to make sure that I'm following correctly. Basically, you are iterating through all the points here. Then for all the other points, you're looking for points that are directly above it. This is your if statement,
exactly.
Right? And here you're saying, okay, I've got one vertical line, and which is this pair, and then you're going to say, we're going to count all the other vertical lines that are exactly on the same level.
Yeah,
okay.
And thanks to the fact that I do it in this order, at this moment, for line with answer plus equal, I add to the answer the number of pairs, the vertical lines that were already processed, and then only I increase the count by 1. So if it happens that first some pair appears, then for a moment this count is 0, so it is answer plus equal to 0, only then I increase the count by 1. And if later on the left or right, doesn't matter for now, let's say, this will be used. The count will be, count is already 1, and then I get answer plus equal 1 when I get to this second vertical line.
Gotcha.
What I'm not sure about is whether maybe I double count, like when I'm on left line, I count the right one and the other way. But then I think this order prevents from that.
Why does the order
whenever
prevent?
I meet the first pair, only then I increase the count by 1, and later, no matter if the other pair is on the left or right, I will increase the answer by 1, right?
I see. Are you when you are I guess we should explore what this make pair function looks like, right?
Yeah, it's just a tuple. I guess this is.
Or no, sorry. Then we should.
Even
I see. I see.
This is also correct. Just I could paste that here and there, and that's it. So it's just not to repeat code.
Right. Okay. So keep going from here then.
Yeah, and I think this way, those two for loops together, they iterate over all the pairs of points. This way I check if I have a vertical line. So here, if I wanted to print those that pair here, this thing would print all the vertical lines, but I don't want to print. I want to count pairs of those vertical lines that are on the same level.
I see.
Each vertical line is defined by pair y, and I want to count pairs that are same. Like some alternative for that would be just to do this, like not to increase answer here, and later if I know that there are, say, 10 pairs on the same level, I could use some simple math formula to say what is the number of rectangles from that. I think it would be 10 choose 2, which is like 10 times 9 divided by 2.
Right.
But I find this one to be more elegant, and here return answer.
All right, you do have the answer from here. Okay, now I understand what you're doing. At first, for some reason, I thought the make pair you were right. That was a function, and forgive my C++. I thought that was a function, and you were kind of going through and counting all the pairs. Now I understand. So wait, just walk me through then this example, because yes, you're right. Because of the ordering of when you increment the count, it works because you're only ever going to find a rectangle when you are on the right side of that rectangle. Right?
Exactly. Like assuming that I go for points from left to right, and the cool thing is that thanks to this order, like I don't actually care left or right. I count it when I meet the latter of two vertical lines, which is in whichever order I go through.
Right.
Just like if I went through a set of numbers, say 5, 7, 5, 2, 4, 2, 7, 5, and I wanted to count pairs of equal numbers, I could go do that from left to right, and for every like this 5 add to the answer the number of already 5s in the set. But if I did that in some scrambled order, like 5, 2, 7, 5, 5, and so on, it would be the same thing.
Right.
And yeah, indeed, let's go through the example. It is sometimes dangerous, but for now, let's say that the order is like that. But my code doesn't sort points, and I claim that the order doesn't matter. If I do it like that, and first p is 1, then the only, actually non-p above will be valid here, because I'm looking for a point that is above.
Like you would never get
will be skipped.
The if statement would never pass.
Exactly, this will never be satisfied. But when p is 2, when this is the second point on the drawing, then here 1 will be a valid point above. The x-coordinate is same. Py, so second point is below y. I assume that y-coordinate grows up. So this is true. Then I go here. I create a pair of y coordinates that are like this y and then that y. And for sure map first has just zeros as values. So this does nothing. And in some languages I would maybe need to put explicitly 0 here, but in C++ it isn't important.
That's fine,
And then I say there is a vertical line like that. If you ever again meet vertical line that is with exactly same y above and below, then you have a rectangle from that.
Right.
Okay, so this is what happened. The count of this pair of y's is 1. And what happens later? When p is 4, then p above as 3 again will satisfy the condition. Like before that, if p is 3, nothing is above.
Yep.
So my code shouldn't find anything here.
Yep.
And yeah, what then we do? The pair y is the same pair as before because the y coordinates are same.
Yep.
So this will do answer plus equal 1. And then we increase count even more, so count becomes 2.
Yep.
It was 1 before. I think there is... Oh, yeah, that's nice. Now count is 2. And eventually when we are at 5... no, not 5, 6.
5, nothing happens again.
This one is 5, exactly. So 5 is skipped. And for 6 and 5, the same pair of y's is there. Answer is plus equal additional 2. And later count will be increased even more to 3.
Yeah.
But I don't care about it anymore because that's it. And the answer is 3. 1 plus 2, as we expected.
Okay, so
if I wanted to be more careful with that, I would just check also what happens in a different order, I guess.
Yeah, that's what I was going to ask. Does this break if you're...
The thing is, I never compare x coordinate. Like if I say that this is 1, 2, 3, and 4, my code... like the first pair that will be encountered will be this 1 and 2, just in different order.
Yeah.
But in the like the below is 1, this one is 2. But what happens here with answer and count is the same thing. Nothing is different at all. The y coordinates are the same. Here I do not compare x. Never. So I don't distinguish, and it's just about the order. For a pair 1, 2, I will increase the count by 1. For 3, 4. Later the answer will be increased by 1 thanks to that.
Yeah.
So in sum, I don't care what order, I go through all the vertical lines, and also for each new vertical line I need the number of previous vertical lines that were at the same level above and below.
Right.
Yeah, so I'm quite confident now with this solution, and the complexity will be n times n, because there are 2 for loops, if n is the number of points, times inside, pessimistically every time I can go inside this if, like I guess it's possible if everything is on one vertical line. And here I use a map that in C++ is log, so this thing is O of n squared times log of n, well, log of n squared, but this is in math the same as log of n, it's only a constant. Like 2 goes before the logarithm.
The log of n
is
coming
get rid
from...
of logarithm.
Yeah, okay.
Logarithm is coming from C++ map. Well, I think some other languages already have that by default constant. And it's about just changing this to unordered map and writing some small piece of code to handle pairs there. Like C++ is stupid about it.
Sure. Yeah, and we don't need to get into that.
And here we go. I have n squared solution. For now, I have no idea how I would speed this up if I need it. Or should I think about it?
I'm not sure that... I don't think we need to go into that. I'm not sure that you could, mainly because you ultimately, like... There is a worst case where the rectangles are, let's say, all on the same line, and not the rectangles, all the points are all on the same line, and any optimization that you might try to do, you would end up having to iterate through every point, and for every point, iterating through every other point. Yeah. So I don't think that you could do better than n squared. Let's not dive into that. As far as space complexity, it's also it's O of n, I think, here, right? Because you would have...
what do I put? I have a map with those pairs, and specifically all the pairs will be different. So for even a bunch of n random points, I have n squared.
So right, n squared, because you would have a pair for every 2 points. Yeah. Okay. So I think there might be a way to improve the space. We actually have a solution on AlgoExpert for this problem with O of n space, but I don't think that that's super interesting here. I'm not too concerned about that. We can talk about that maybe later. What I do want to explore, since we do have time, I think we still have like 25 minutes, 27 minutes. Super quick pause. I just want to share my thoughts on the first half of the interview. As you saw, Camille did very well as far as the coding and algorithm design part of the interview is concerned. He came up with a solution that was very good. He did it very fast. He was able to actually code it out. So really fantastic job on his part from that point of view. The one little piece of constructive criticism that I would give here is that he was so good at this that he kind of forgot to communicate a little bit more his thought process. Since I had never seen the solution that he actually came up with, I kind of got lost in the middle. You kind of saw that when I wasn't quite following what he was saying, and I had to kind of catch up to him. And so here I think that he just could have communicated a tiny bit more, voiced his thought process a tiny bit more. But otherwise, he did a fantastic job. And now, as you'll see during the second half of the interview, this is where I really tried to challenge him with something much harder, and this is something that interviewers will often do when they're dealing with such a strong candidate. They'll give them a problem or a tougher variation of the current problem that they don't even expect the candidate to find a solution to. They just kind of want to see, how does this candidate, who's obviously really good, deal with a complex problem, something that they're probably not going to be able to solve. And so this is what you're about to see. Enjoy. I want to explore what we said at the beginning of what if now we have rectangles that can be diagonal. So something like this. Let's put 7, 8, 9. Whoops. And here, like you pointed out, there's a rectangle.
But there's, for example, this one.
Yeah, I'll put it in
or even
green.
Something that is more tilted, that isn't very regular.
Just so that the viewers can understand what we mean. Yes, exactly what you said. This rectangle in green here is sort of diagonal. It's not horizontal or vertical or whatever the word is. And how do you compute that?
So this is part that maybe normally I would need to think about, but I'm good in computational geometry, so I know what are like vectors and cross products, dot products here. And the thing is that then, like before we could define this way, when 4 points create a rectangle, now we need to modify that quite a lot. I will just move the first solution below to work here with example more. That if, let's say for a moment that the first point of a rectangle is 0, 0, we can later put something more complicated here. And then if the other is x, y, and some third point is x2, y2, then if those two are neighbors of 0, 0, then I want a right angle between them, the 90 degrees.
Right.
And there is a formula for that, that is cross product. It will be x times y2 is equal y times x2, which basically is also possible to figure out without knowing the terms, because I remember that I used to, like, when I needed something like that and I didn't know the formula, I would just draw an example of such a rectangle or right angle. And if you put like 0.51, then you try to match which point would create indeed a right angle, and then you see that, like, for example, did 1, 5. So this is that point, and minus 5, 1. Those two would create a right angle with 0, 0, and from that you can figure out what needs to be called. Also, if you put it this way, the distance doesn't matter. So that's one part. Now I'm already able with formula to count the right triangles. I mean triangles that have a right angle.
Right. So like 1/2 of the rectangle.
Yeah. Now what do we need? I think this thing allows me for first O of n to the 4 solution, where I would iterate over all the 4s of points, and I would check some formulas. So I need to check the right angles plus some other thing, or maybe if I check all the 4 angles, then that's it, because something that has 4 sides and 4 right angles, I think, is a rectangle.
Yeah.
I wanted to say that I also check some distances, but it doesn't sound necessary. And so that would be just for loop point A, for loop point B, for loop point C, for loop point D, if and here a lot of ifs for those for this stuff. Plus, this doesn't have to be 0, 0, but then I can shift the drawing to put the point in 0, 0. I can subtract things, or just think about vectors, not about points, about vectors, the sides. For now, do I go in the correct direction?
So
Is everything fine?
So it's interesting because I've actually never solved this version of the problem. I just had it in the back of my mind as a way to like make this problem much more difficult that I wanted to explore with you, but I don't know how to solve this problem. So I'm finding it interesting that you're going with this approach. In my mind, I was thinking maybe we could solve it by figuring out like that you need the same like rise over run, right? You need the same what's the name of that?
Slope?
Slope, yeah. But I haven't done math in so long. You need the same slope on like the two parallel sides, and
Actually, I might want to try that in a moment because I don't know where I'm going. By the way, if I got something like very hard and indeed I would be stressed, then also I would take that like 5 minutes of thinking before jumping into like going through everything.
Right.
Here, even with the first version, I tried to just not make a pause, instead to just dive into it. And I thought that, I will likely get a good complexity. Here I'm more like blind and we'll see where it goes. Yeah, so I can think later about like what to put here, but I am able to check for the right angle. If you ask me later, I will code something for that. It uses this formula.
Right.
But then, like one technique I like for speeding up polynomial solution, if you have a lot of for loops, is to just remove the last for loop. And the thing is, if you have 3 points and they create a right angle, you should know where the 4th point is.
Yep, that's true.
And like, because
and if you
let's say they are A, B, C, D in this order, then vector AB, let's mark it this way, is equal to vector, say, DC. Like the two sides, they're parallel and equal, so vectors are the same.
But even like, just to put it even in simpler terms, without even vectors, like if you have 3 points, then you can deduce the x and y coordinate of the 4th point based on those 3 points, right?
Yeah, with some like computation with coordinates.
Yeah.
So here, that in other words is b minus a is d minus c. So I get d is c plus b minus a, what means that point d is c dot x plus b dot x minus a dot x, comma, the same for y. And this must be point d. And to check if such a point exists, I can use a hash map. Hash set, actually, it's just to check if something exists at that position.
Yep, of course.
One more thing to keep in mind, now I got rid of that, one more thing to keep in mind, just like with previous solution, is not to overcount something. Like, I don't want to count the same rectangle 4 times, or if I understand that I do, at the end I can divide the answer before printing by 4. When coding is done not on whiteboard, but with like computer, then I would usually implement something, see the answer, and if it's too big, then divide by whatever I need to divide by.
Right.
Here, after coding some code for this, I would just analyze it to see if I overcount. Then I would handle that, just like with previous problem.
Right.
And we have now n cube. But to go even faster.
Yeah, the question is like, is there a way to make? Again, I think we established in the first solution that I don't think there's a way to beat n squared. I don't think you can beat polynomial time for this problem. But can we get that n cubed down to n squared with the diagonal diagonal expansion thing?
I have some ideas. One is what you said about slope. Well, it wasn't my idea, but this is something. Let's call it idea number 3, slope. And two more are, first one is from points A and B, figure out where C should be. So get rid also of this for loop.
Right.
Like if you have A and B here, then C should be somewhere on this line, but it would be hard. Like I cannot iterate over that C.
And the thing is, here in the example that we have, we're dealing with actually a very edge case example where, let's say...
Yes, it can be tilted more.
It can be tilted, yeah.
So that's something. Second thing is, this is something that I would never come up without seeing first, that we can consider the middle point of a segment, say AC.
Yeah.
This will be a crazy idea, but it might just work. The thing is, if AC is diagonal of this rectangle, then I can iterate over all the pairs of points. Consider, hey, maybe this is diagonal of a rectangle.
What are the properties of diagonals of rectangles that are interesting? Do they always...
The thing is the two diagonals intersect exactly in the middle.
They do, right? Yeah.
It is possible that what I will get from this approach, from this idea, is not a rectangle, but let's say a rhombus. I don't know words in English, but
right, because there are other shapes where the two diagonals intersect in the middle that are not rectangles, right?
I would need to think.
Now we're getting into like there might be a way to like find these I'm going to call them hacky solutions that rely on the underlying like math principles. But I wonder if idea number 1 or number 3 that's sort of more accessible in a way.
Yeah.
I feel like
because 2 is very random and you cannot just get that by thinking. I just remember that I saw some problem that uses this.
Right.
Maybe even this problem, to be honest, because some of them are similar. So let's investigate 1 or 3. And I'm like removing this one.
I think 1 and 3 are actually kind of similar, right? It's the idea that you've got the first 2 points. Maybe you use the fact that they have a given slope. How do you find C and then D from there?
Yeah. Okay, so I will try A. I will try the first one because it was my idea.
Sure.
So maybe I can manage to solve this problem. Later I can try slope. So from points A and B, figure out where C should be. I'm not able to iterate over C because like then I have iteration over 3 points. Maybe it amortizes in some very magic way. I don't think so. So instead, I will write down some thoughts maybe. So let V denote vector V. Let denote like from A to B. Then let V prime denote a vector or direction perpendicular to V. So from this direction I would get this one, and I know C must be somewhere around there. Among points C that are on direction V prime from A.
Yeah.
Let's say. So from A, I want to go along that direction, like not necessarily within the same distance. V prime is just like perpendicular direction.
Yeah.
Necessarily within some distance. I want to count those that have a matching point D, such that CD is V. So if from A to B I went, let's say, 2 units up, then also from that C that is somewhere else, I want to go 2 units up.
Yeah. But to be honest, Camille, I think you just did it. The key is the perpendicular. If you can find the perpendicular ones in like constant time or something, you've got your solution. Because once you find all the points C on the perpendicular vector, then D is just a matter of storing all the points in a hash map and finding the D that has the correct XY coordinates,
And
right? That fourth point is always
I'm just worried
easy.
about very strange tests where maybe, I think I am able to find quickly those C, but if I iterate over those to see what should be the matching D, I think then the complexity is again n cubic. Because let's try. I anyway need that, so I will say that too much to find those C. What I do is for every point A in points, point A in points, for point C in points, and now this will be, let's call it deer map from a tuple that contains A and get vector of from A to C. For a moment, let's say plus plus, just to count.
Right.
And this get vector, it should not only compute the vector, like from A to C, but also I care about direction, not about distance. And there is a way to handle that. Like, let's say I create a get vector function.
Yeah.
From point A to point C. Then x is cx minus ax. Int y is cy minus ay. This is the vector, but I don't want to distinguish vector 1, 1 from vector 10, 10. I care about direction.
Right.
One thing here would be to compute the angle, but that's always a bad idea because of like precision issues, stuff like that. But in short, it's good to normalize this.
Wait, but don't you want to distinguish? You do want to distinguish them, no? Like,
the thing is, I will finish that in 1 second.
okay.
So return point made of x over g and y over g. And this is not working for zeros or negative for now. The thing is, I use it for that. For A, I want to find all the points C that are in this direction. Let's say in direction 1, 1. But also, point that is 10, 10 from here is okay. I care about direction. The example would be, let's say that B is minus 1, 1, A is 0, 0. So now I'm looking for all the points that are like, the valid points C are like 5, 5, 13, 13, and so on. I think those will create, like, this is left up, this is right up. I want to find all of those, and if I don't do that, then in a map I would store only a point 1, 1. Like I want to, those are fine too. So after I do my thing with get vector, I will move the whole thing to another page to have it on like in one place.
Yep.
After I have this deer map thing, when I iterate over A, iterate over B, then I can do what I wrote down above, that let V prime denote a vector direction perpendicular to V. So I do that with some formulas. V prime is perpendicular of from A to B, it's something, and then I read deer map actually perpendicular of get vector of AB. So get vector finds me a normalized vector between A and B, perpendicular rotates by 90 degrees, and then here use deer map from A with this direction.
Right.
Because that will now find all the points that are here.
Yeah.
For now, I'm not even close to counting rectangles because I cannot iterate over elements here, because then it's a third for loop.
Well, it depends though, because what if you can pre-compute the 4AB, right? You can pre-compute all of the lines that go from A. You can pre-compute all the vectors AB.
Yeah, I can.
In n squared time, but then you pre-compute them in n squared time. Oh, but wait, do you have n? No, you don't have n squared lines then. Wait.
Like I can find them in n square, and now I need to, I think, modify in some way the dir map. In some way.
Look,
I have a feeling that
if you have, you can pre-compute all the lines that go from a point in the bottom left to the upper right in n squared time, right? You can pre-compute all the ABs in O of n squared. And so then for every AB, right, for every AB, and there are as many ABs or fewer than the number of points, so they're at most O of n ABs. For every AB, you can do your get vector AB, your perpendicular thing, right? Which is going to be also O of n. So for AB, I'm writing really pseudocode. For AB, do get perp. And this is also, it's like n lines AB that do an action of O of n. So n lines AB.
Is it n? I think like there can be n square pessimistically, right? Like the.
Well, no, because you would have at most n lines. Like you would have. Because we're only dealing with lines. At least maybe I missed that thing from you, but in my mind, you only deal with lines that go from a bottom left point to an upper right point.
I mean, we can deal just with those where the both x coordinate increases and y coordinate increases, right?
Yeah.
Not necessarily 45 degrees, but then still pessimistically there are n square of them. Just if you put a bunch of lines that go roughly along the line y is equal x.
Oh yes, in the worst case, case there are n squared. Yes, in the worst case.
So my guess for now is kind of maybe intuition, is that here I want to use that, but also to consider points D in some way. So the dir map is not just this. I think that this thing now would count the number of triangles with right angle. And if I want this thing, and if I want the number of rectangles, so also to consider D without iterating over C, because I'm afraid that would be n cube, unless maybe there is some amortized complexity going on, then when I create dir map, so from A to C, I need to at this moment curves in some way about points D that are perpendicular to AC, but that is overwhelming.
Well, do you need to do that, or can't you just at the end at that point just decide based on coordinates that you've collected where that point D would be?
The thing is that here right now my dir map only stores the count,
right.
the number of points C. I could here say this dot append or pushback in C++ C. Then here I would be able to iterate over matching point C, but then n cube.
Yeah.
Okay, one more idea that it's kind of like related to this normalization thing is that maybe it's better to think for a moment about the previous code, the one that solves the easier version of a problem. So iterate over all the pairs, say AB.
Yeah.
And let's say I want to achieve the same thing, to just increase the counter for those pairs. There I had the counter for pair y coordinate, one y coordinate.
Right.
Just here, it's not a pair of y coordinates, it's a vector. Let's say that says from A to B you go 2 up and 2 to the right and 5 up.
Yeah.
you want to find matching with those, but also at the same not only matching vector, because then if AB and CD are same but in some different positions, you don't get a rectangle.
Wait, so if you go with that approach, if you go with your approach of like the lines, right? There are only two conditions that you need. Like the vector comes down to you need matching lines of the same slope, and you need matching lines of the same length, right?
Sounds like I will get what is called równoległo bok in Polish. Let me Google that.
What is that?
Parallelogram. Four-sided thing that has like both pairs of sides parallel to each other.
Yeah, you will get parallelograms if you do that.
Like tilted rectangle. But I think I have a solution here, so I will type like 2 sentences and then work on that.
Okay, and by the way, just as a side note, we only have 2 minutes left, so in the effort of keeping this,
easy. Easy. So for every vector AB, I want to normalize it in some way. So I want to increase the counter of the vector V, and where point A is with respect to perpendicular of V. I will explain that in a moment. And that normalized thing, what it should do, the pseudocode of that is, let's say, while AX is greater than 0, A minus equal the vector. And I think that does the job. And now what I hope it does is
the normalize function.
yeah. So this is a function and this is a pseudocode for that, but also I can do a formula that is constant time. And this works assuming that like x coordinates are positive. What I mean is, if you have AB, like a segment that is somewhere, what I want to do is I want to push it, let's say, somewhere around point 0, 0. If A is, say, 3, 3, and B is 3, 7. So this is like a vertical line, by the way, but I don't care about it. From that, I want to normalize it so that I want to get this. I want to shift it so that this would be true. So I will get 0, 3 and 0, 7. And then if A is, for example, 10, 3 and B is 10, 7, to normalize it to this thing, I will get the same stuff. So by normalizing, I first change every pair to such a normalized one, and then I claim if two things gave me the same normalized pair, they create a rectangle. And this is extension of our first version of a problem, I think.
Right.
Where here I just shift by vector perpendicular to IB, and here because I had vertical line, what I did is I shifted by horizontal line, just to the left.
Yeah.
So I think that this gives us n-square solution.
Yeah, this would be interesting to code out. Now we ran out of time, so I think we're gonna, and also in an effort to keep this video contained, and to mimic a coding interview, we're gonna stop. But this would be really interesting. I want to just do a very quick debrief with you, Camille. So first of all, great job. I think this is really, for those of you watching, this is a perfect example of the kind of real coding interview that you could get at a company like Google. And it's a perfect example of a question that, first of all, is very difficult. I think the first part of the question was very difficult, and most candidates would struggle through that first part during most of the interview. But here we were able to or Camille rather, was able to stretch the question and dive into a part of it that's just really, really difficult and really new, where he's working to try to find a solution. The interviewer is not expecting a perfect solution for the second part. We're just looking to see how this candidate can solve the problem or try to solve a problem. So really great job from that point of view. And also I want to say, Camille, your solution to the first problem, I can't find it anymore at this point, but the one with the lines, it's funny, it's actually different than the 3 solutions that we have to this problem on AlgoExpert. We came up with 3 solutions that are all 3 different than your solution. So that was kind of cool to see.
Okay, that's interesting. I find it funny, by the way, about the second version, that at some moments we just worked together with that because it was like interesting hard problem, and you also for some moments like also tried. Maybe this works. Maybe this works with that one. Also, the slope idea, of course, I didn't investigate that much. Yeah, but I think also helps that interviewer doesn't just watch, but he should give hints and also be some kind of sanity check help.
Yeah.
I think if I said something very, very stupid, there would be at least a question, why is that?
Definitely.
Otherwise, I could go into that direction and waste half an hour.
Definitely. And I think that for these kinds of problems that are hard, again, I think that this is a problem, even the first solution or the first version, that is quite difficult. It is going to be expected that this is going to be kind of a problem that you're almost solving with the interviewer. You just happen to be the person kind of leading the interview. They're just there to kind of give you, little hints here and there, but overall you're the one leading.
Yeah, it would be strange if it was the other way around. Right?
Of course. But awesome. That's going to be it, I think, for the interview, Camille. Any last thoughts on your end?
Well, I thank you for geometry problem, because then, as I said, I'm good in geometry, so I think now people will treat me better than I am actually, because this is my area of interest. Problem was hard enough, the second version indeed. So in a lot of problems, including the first version, it's just that I already knew a problem that is similar enough. Because I solved thousands of problems in my life. And here the second version, maybe the middle point would work immediately. I'm not sure now about it, because I saw a similar thing with that solution. And it was nice to investigate something for half an hour, get some help from you, and indeed show, I guess, how coding interview should look like.
Yeah, and that goes to show you, by the way, just to what you just said about the first version, that if you practice enough, and if you do enough of these problems, you will be able to do even very difficult problems like this one pretty easily. Like Camille just said, he hadn't seen necessarily this particular problem, but he's seen similar ones, similar patterns, and so he was kind of able to nail it.
Yeah, that's true. And by the way, you don't need to solve like thousands of problems, because you don't need to solve a Google interview problem in seconds, like to know a solution in seconds, to pass an interview.
Of course. Again, like here I think you did fantastically in the interview, especially in the parts of like algorithm and design and data structures. These kinds of parts you really did fantastic. But I want to make it clear to the audience that you do not have to do this well in the algorithm and in finding a correct solution to pass the interview. In fact, again, for this particular problem, for the first version, I probably wouldn't even expect the candidate to code out a fully working solution. So just to put things into perspective, that here, Camille is just really performing super well, but he's also like a competitive programmer.
Yeah, I'm kind of professional in solving problems, and usually people practice it for, I guess, a few weeks.
That's such a badass way of describing yourself. Like, you are a professional problem solver.
Yeah, I think that's a nice way to put it.
All right, well, that's going to be it, I think, for the video. Thanks so much for being here, Camille. And if you enjoyed this video, make sure to give it a like and to subscribe. And also, we filmed another video on Camille's channel where he interviewed me, not in a coding interview, but more kind of getting to know me and asking me questions about, my math background and these kinds of things. So if you're interested, I'll put the link in the description and in the comments below. Be sure to show him some love, and I'll see you in the next video.